Algebra 2, Chapter 13.3, Exercise 1 through 11. In this exercise set, I'm going to do the odd number problems. 1. Graph the function f(x) equals 1/3 the power of x by plotting points with integer x values from -2 to 2. What I'm going to do for that is fashion a table, and we're going to put x values here. We have -2, -1, 0, 1, and 2. And the first thing I'm going to do is make an input of 0. So we have 1/3 to the power of 0, which is 1. And then for an input of 1, we have 1/3 to the power of 1, which is 1/3. And for an input of 2, we have 1/3 to the power of 2, which is going to be 1 over 3 squared, which is 1/9. And then we have, for -1, we're going to have 1/3 to the power of -1, which is equal to 1 over 3 to the -1, which is going to be, you take a negative power in the denominator and move that up to the numerator. So we're going to have 3 to the 1 power, which is 3. Okay, and then for an input of -2, we have 1/3 to the power of -2, which is going to be 1 over 3 to the power of -2, which is going to be equal to 3 squared, which equals to 9. So we have 9. So let's go ahead and put this in here. -2, we have 9. For input of -1, we have 3. We have our y-intercept of 1. We have 1, input of 1, output of 1/3, input of 2, output of 1/9. And then sketching the graph. I'm going to try to get as free as I can. It's really clumsy to do this in my digital pen. Okay, so we have this. Okay. And you really smash up against the x-axis here. So that's our graph. Next set, describe the transformations from each parent function and give the domain and range of each function. I'm going to do the other problems, but the basic things we're looking for here, if we have a function of f of x equals, we'll say, for number 3, 1/10, we'll have a times 1/10 to the power of x minus h plus k. Okay, a, if negative, will reflect about the x-axis. Okay, I'll put if negative, reflect about x-axis. And then also vertically and horizontally stretch, and vertically stretch and compress. That's what I meant to say. Stretch or compress. Okay, and then H will be a translation left or right. And then K is going to be translate up or down. Okay, now for this one here, g of x equals 1/10 to the power of x plus 4. We're going to have h is equal to -4. And why is that? Because to have h, to get x equals 4, we have to have x minus -4. So h is -4. So for number 3, we have f of x is translated four units to the left. Okay, so and as far as the domain and range, our domain is going to be greater than negative infinity, less than infinity. And our range is going to be greater than 0, less than infinity. So that's it for number 3. Not too complicated. Okay, now number 5. Here, number 5, we have a is equal to 3. We have here to the power of x plus 3. So h is going to be equal to -3. And k is equal to -6. So for this one, our parent function f of x equals 1/2 to the power of x is vertically stretched by factor of 3 and we have horizontally translated, I'll put a comma here, horizontally translated, and that'll be 3 units left. And then we have k is equal to -6, so we're vertically translated 6 units down. Okay, and what is our domain going to be? Our domain is going to be what it always is for exponential functions, greater than negative infinity, less than infinity. And our range, we translated the function down 6 units, so our range is going to be greater than -6, less than infinity. So that's problem 5. Now next set, for each of the transform functions, use the reference points and the asymptote to draw the transform function on the grid. Then describe the domain and range of the transform function using set notation. Okay, so now, number 6, we have a is equal to -2. We have to the power of x minus 1, so h is going to be equal to 1. And we have plus 2 on the outside here, so k is equal to 2. And the k equals 2 is the first thing I'm going to notice. So that's going to be horizontal asymptote. That's going to be y equals 2. And then we're going to go about transforming this. Now, I'm going to do the odd number problem, so I'm just going to leave this at this point for you to work with and go on to number 7. So what we have here is, for number 7, We do not have an A, but we have K is equal to -2. Or H is equal to -2 is what I meant to put down. I'll get it right here. So H is equal to -2. And then we have K is equal to 3, which becomes our horizontal asymptote. So horizontal asymptote y is equal to 3. So our reference points are going to be, original reference points are going to be 0, 1, because we put 1/4. So the power of 0, that's going to be, and then we have, for other reference point, we're going to have -1. So g of -1, or I'll say f, because for f of x equals 1/4 to the power of x, f of -1 is going to be 1/4 to the power of -1, which equals 1 over 4 to the -1 power, which equals 4. So our other reference point is going to be this one here. -1, 4. So these are our reference points. So reference points, we have 0, 1 and -1, 4. So these are the points we're going to transform. The first thing we're going to do is we're going to take 0, 1, and we're going to have for h is equal to -2, as we take 0, 1 and translate that point 2 units horizontally to the left, we'll take 0 minus 2, which is going to be -2, and we carry over the y-coordinate unchanged, which is 1. And now we're going to take this for k is equal to 3. We bring over the unchanged x-coordinate, -2, and take 1 plus 3, which is 4. So this is going to be our transformed reference point. And now for the next one, which is -1, 4, for h is equal to -2, we're going to take this -1 minus 2 to get -3, and we bring over the 4, and then we have k is equal to 3. We're going to bring over the -3 unchanged, and then take 4 plus 3, which is 7. So this is going to be our other new reference point. And now we can graph these reference points here, -2, 4, because we move this point 2 units to the left and 3 units up. The next one is -3, 7, -3 up to 7. And then graphing, we're going to go like this. And smash up against this x-axis, the horizontal asymptote like this. So that's it's going to look something like this. Now for domain and range. Okay, our domain is going to be in set notation x such that x is, you can put x as an element of all real numbers, but you can also write it like this. X is greater than negative infinity, but less than infinity. Okay, so that's going to be set notation or domain. Range is going to be y such that y is going to be greater than our horizontal asymptote, so y is going to be greater than 3. Okay, we have our reference points, our domain and range. That's it. Okay, number 9. Okay, in this case for number 9, we have a is equal to 2. For our exponent, we have x minus 2, so h is equal to 2, and we have k is equal to negative 3. So we go ahead and take our, go down here, we'll put horizontal asymptote, y is equal to negative 3. Okay. And our original reference points are going to be 0, 1 and negative 1, 4, just similar to number 7. Because if we have for f of x equals 1/4 to the power of x, we're going to have, we plug in 0, we're going to have 1/4 the power of 0 is 1, so we're going to have 0, 1. If we plug in negative 1, we're going to have 1/4 to the negative 1 power, which is going to be 4. So there we have our reference points. Now, we're going to take these reference points and transform them to be able to sketch this graph. So we're starting out with, I'm going to start out with 0, 1. And for a is equal to 2, right? A is equal to 2. What a vertical stretch by a factor of 2 looks like, this point is transformed to 0, 1 times 2, or 2. Now we're going to take, for h is equal to 2, we're going to take 0 plus 2, or 2, and the y-coordinate is unchanged. Now for k is equal to negative 3, we're going to take our x-coordinate unchanged and take 2 minus 3, which is negative 1. So this is going to be one of our transformed reference points. And now for negative 1, 4, for a is equal to 2, it's going to take this y-coordinate and multiply it by 2 to get 8. And next, for h is equal to 2, we're going to add 2 to negative 1. So negative 1 plus 2 is 1. And then we have for k is equal to negative 3, we're going to take this 8 and subtract 3 to get 5. So this will be our second reference point. And now we can graph our reference points at here 2, negative 1, and 1, 5. And the sketch of this graph is going to look like this. This point here, and then we break kind of sharply to the right. So it'll look like this. And now finally for domain and range. Okay, our domain. Okay, we're going to have in set notation x such that x is greater than negative infinity but less than infinity. Okay, and our range is going to be y such that y such that y is going to be greater than negative 3. So that's it. We got our domain and range and set notation. So next, and the last one we're going to do in this set is number 11. Here we have a negative sign out front. We have g of x equals negative 2/3 the power of x plus 1. So a is equal to negative 1. We have to the power of x plus 1. So we have h is equal to negative 1 because x minus negative 1 is x plus 1. And finally we have k is equal to 1/2. So our horizontal asymptote is going to be y equals 1/2. Okay, now to find our reference points, to use the first one, for f of x equals 2/3 to the power of x, f of 0 is going to be 2/3 to the power of 0 is 1. So that's going to be the reference point 0, 1. Okay, so right here, I'll put 0, 1. It's one reference point. And then for f of x equals 2/3 to the power of x again, f of negative 1 is going to be equal to 2/3 to the power of negative 1. What that's is going to be is 2 to the negative 1 power over 3 to the negative 1 power. And what that's going to do is it's going to take this 2 to the negative 1 power becomes 2 in the numerator, becomes 2 in the denominator, and 3 to the negative 1 power in the denominator becomes 3 in the numerator. So we're going to be equal to 3 halves. So our point is going to be, reference point is going to be negative 1, comma, 3 halves. So we take negative 1, comma, 3 halves. So now we're going to do our transformations. We'll take 0, comma 1, and we're going to say for a equals negative 1, this 0, comma 1 is going to be negative 1 times, 1 times negative 1, or negative 1. Now for h is equal to negative 1, we take this 0 minus 1, which is negative 1, and the y value becomes unchanged at negative 1. And then the last thing we have is for k is equal to 1/2, we're going to have, I draw these arrows as I go to the right, we have for k, for x value unchanged at negative 1, and for the y value, we're going to have negative 1 plus 1/2, which is going to be negative 1/2. So this is one of our transform reference points. And next we have this one, negative 1 comma 3/2. For a is equal to negative 1, this point becomes negative 1 comma 3/2 times negative 1 is going to be negative 3/2. And now for h is equal to negative 1, we have negative 1 minus 1, which is negative 2, and we bring over the negative 3/2. And finally, for k is equal to 1/2, we bring the negative 2 over unchanged, and then we have this negative 3/2 plus 1/2. That's going to be like negative 1.5 plus 0.5, that's going to be negative 1. So this is going to be our second reference point. And now I'm going to draw these in red according to convention. So negative 1, negative 1/2 is going to look like this, right? 1 to the left, 1/2 down. And then we have, the next point is going to be negative 2, comma, negative 1. So it'll look like this. So our graph is going to look like this. I'm going to bump up here against the horizontal asymptote. Okay, and then for our domain, we're going to have, in set notation, x such that x is greater than negative infinity, not less than infinity. And for a range, we're going to have, now we're coming from negative infinity from down below, so we're going to have y such that y is less than our horizontal asymptote of 1/2. So that will be our domain and range. And just looking back quickly at number 10, we have a is equal to negative 3. We have h is equal to negative 2, and we have k is equal to 7. So anyway, this is as far as I'm going to go in this video lesson. Good luck in working out the other problems, and thanks for viewing.